is live. Let's see. If you would, and you haven't yet, go ahead and please say something, at least in the YouTube chat, just so I know you're here and I can mark you present. Schedule for Friday. I think let me look at what's on the plan. But I think what's the plan for Friday is you'll just continue on with labs for 8.3, as well as those additional volley labs that I've provided. So that's the volley labs is the main thing you'll be working on Friday, in theory. I'm also planning to do a stream on tomorrow, because I'll go over the theory here today, but I'm also planning to do an actual example tomorrow with how to fit in notifications and volley and all of that together tomorrow. No, there's not, as far as the uniform code goes, there's nothing as far as that's concerned. Obviously, when we do presentations at the end of the semester, I would expect you to be, in uniform for those. But other than that, it's up to you until we resume in person or the end of the semester. Well, if anybody sees Graham, let me know. I think we got everybody here except for Graham. So I'm going to go ahead and come back. Oh, for me, they didn't really say. I mean, obviously, I'm recording this and putting it online, so I'm trying to at least say, mostly professional. Because I assume this is something that my students next year will see as well. So I want to make sure that it's okay for that. But it's cold, so that's why I've got another kind of layer on. All right, so let's get rolling on 8.3. Again, if you have any questions during the stream, just ask them as is whenever they come up, and I'll get back to you whenever there's a break, a chance to answer that. Okay, let me get this into full screen mode. Nope, I don't want that over here. I want that here. There we go. So 8.3, we're going to talk about efficient data transfer using the job scheduler. And one of the things we need to talk about first is kind of what does that mean to transfer data efficiently. So we'll go over that, and we'll talk about how to use the job scheduler to schedule tasks or work you want to happen at a later time. We'll go over the job service, we'll go over the JobInfo object, and then also how to tie that up with the job scheduler object. So, transferring data efficiently is kind of an important thing. When it comes to using resources, the wireless radio is kind of the most important thing that we're going to talk about in terms of what we do here as far as resource usage. Because that's the thing that we have some control over, and that's really what we're focusing on as we're trying to do things in background. Usually means network activity. Background activity can also be things like, hey, I just want to clean up the file structure, or I want to maybe optimize or compress some data. There's a lot of things that you could be doing with files or processing work that you might do with jobs that might need to happen in the background. But the main thing that we're going to focus on is connecting to the internet, doing things where we're retrieving resources from the internet. So that's our main focus with the job scheduler. So the wireless radio, anytime you communicate with the internet, it's going to use battery. We got to be kind of careful about that because eventually the device is going to run out of battery, and then the user is going to need to let it charge. That's not terribly convenient. Nobody really likes hanging around a socket, an outlet, waiting for their phone to charge or being plugged in, or having to lug a battery around to be able to use your device. Ideally, we want to be able to just have our device last for a few days and not need a charge. So it's kind of important to make sure that we're using that data and that battery in an efficient manner. Some people also have data plans. I know one of you on here is using a hotspot, that costs something. So you got to think about that too. You don't necessarily want to be using up a lot of their data plan because that costs them, in the end could cost them money. It can even cost them money if the app is quote unquote free because they have to spend money on that data. So that's something that you really want to keep in mind in terms of optimizing data, in terms of optimizing the battery usage. So, as far as working with the wireless radio's got three main power states. And this varies a little bit by hardware or device, but you can usually break it down into these three parts. So for full power, that's what's considered an active connection. You're actively sending or receiving data, and that gives you the highest data transfer speed. Typically, in order to use the radio, in order to send anything to the internet, it has to get into that full power state. But that full power state is where it uses, obviously, the most power. Then beneath that, there's an intermediate, a low power state. Uses maybe 50% of this battery, 50% as much power. It does vary quite a bit by what kind of technology or what radio you're talking about. But typically it will use less battery in that sort of lower power state. Then beneath that is what we've got, the standby state. It's the least amount of energy used, and that's basically when nothing is happening. When you're not sending or receiving data, it's going to be able to get into that standby mode and be able to conserve battery life. Okay, so there's a transition time for going between those three states. So at the highest state, you've got the radio full power. That's, hey, we can send data, we can send it at max speed. Typically, it takes about 5 seconds after we're not using the radio, after we're not sending any data, for then it to go back to the low power state. And then from the lower power state, it takes about 12 seconds to go down to standby. So anytime you use the radio, it's going to be active from when you finish it. It's going to still be active for those next at least 17 seconds. So that's the thing to kind of keep in mind. Even though you've finished using the radio doesn't mean it immediately turns off. But there's also in there, you can kind of see on the diagram that there's also time for it to turn on. So if we go from standby to on, it takes 2 seconds to turn the radio on. So that means that there's a 2-second delay on any network activity that you want to do. If you want to go get data, you're going to have to wait 2 seconds for that radio to turn on, and then it could make that request out to the internet. Similar thing here, if it goes from low power to full power, it's going to take about a second and a half. Again, these numbers, all of these 4 numbers vary depending on what kind of hardware you're using. But that's generally a thing to keep in mind, is it takes time to ramp back up, and it also takes time for the radio to turn off. The reason that we take that time to turn it off is because there may be other things that come in that may need to use the radio at that same time. So we try to keep it kind of on for a little bit longer so that those things can keep going, and then shut it off when we decide that nobody's sending anything anymore. Okay. So one of the things that means, practically, those power states is that we really need to bundle our network transfers. We need to have them happen about roughly all kind of clustered together. We don't want to do them kind of spread out, do them once every 30 seconds, once every 10 seconds. We want to do as many things that we can kind of in a narrow slice, a narrow bundle of time. That way the radio can be offline for most, it can be in standby for most of the time. So in practice, say we don't do that. Say we send data for a second. We have a second worth of data sending and receiving that happens every 18 seconds. So that may be like going out to the internet and seeing if there's new articles or new stores or new posts or whatever it may be. We're going to look for new things every 18 seconds. Well, what that means is, because it takes that kind of 17-ish, 18-ish seconds for the radio to turn off, that means the radio never actually gets to turn off. That means that the radio effectively is always in either full power or low power. It doesn't ever get to go down to standby, which means we're using a lot of power. If, on the other hand, we say, rather than sending it 1 second every 18, well, let's say we send for 3 seconds. But we only send for 3 seconds out of every minute per se. So let's say out of every minute, I only send data for 3 seconds. Well, for 3 seconds, we have to be in full power. And then there's that 5-second kind of lead off time before it turns back down to low. So that means we're at least going to be in high power for 8 seconds. And then we'll be 12 seconds in lower power. And that means the remaining 40 seconds out of that minute actually gets to be in standby. That means that most of the time we're running in a low power state if we can do a lot of those network transmissions around the same time. We can bundle them together. So what that means is if we're looking at kind of power usage, if we're looking at a minute of kind of activity, so we're saying, okay, well, let's send it throughout a minute, every 18 seconds, we'll send data for 1 second, and then we'll be asleep for 18 or 17. We'll send for a second, wait 17 seconds. Send for a second, wait 17 seconds. That means that our power usage looks like the diagram on the left. Most of the time we're in low power, some of the time we're on high power, but either way we're using a lot of battery power. Versus bundling things, again, in kind of a minute perspective, if we say we only send for 3 seconds out of a minute, well, then we have this part here where we're in high power and that part where we're in low power, and the rest of this we're idle or in standby. So you'll see is what that means overall is that this is a whole lot better. The diagram on the right is a whole lot better for battery usage, for battery life. It means that we're using a whole lot less data, and it means that we're using a whole lot less battery. Because one of the things to keep in mind is not just is this necessarily using more battery, this is actually also using more data the way it's spread out. So one thing we can do to try and avoid all this is we can prefetch data. We can say, let's down all the data that the user is probably going to use in the next period. In a short burst, we'll just say, okay, when the user loads this screen, let's go ahead and preload all the data we think they might use, and then we'll then we'll save that. We'll reuse that. So let's say they're searching for puppies on Google, right? Well, we can download the search results for puppies, okay? And maybe we say, let's take the first 20 results, and then let's look at the first 5. They're probably going to click on one of the first 5 links, and let's go ahead and load the page for those first 5 links and save all the resources for those first 5 links. And that way, when they click on one of those links for the first 5 pages, they don't have to that doesn't have to go out to the internet to go grab that data. Same thing with any sort of search results, is you can say, let's get those search results, but then let's also, maybe pick and choose grab all the data for the first few results. That reduces potentially how much they have to load. Now, if we guess right, if we guess correctly, then great. This reduces battery life, reduces latency, because we've gotten all that data all at once. They don't have to wait to get that data later. However, if we get that wrong, we pull down too much data or we pull down the wrong data, then it's just we're wasting extra battery life and extra data bandwidth. So it's something to consider. It's something you want to definitely put in your toolbox about prefetching data, but it's also something you have to be very careful with because it's easy to get it wrong, or it's easy to pull too much data or data that's maybe not what the user is going to use anyway. And that also means if we're going to prefetch data, well, generally speaking, that data that we're prefetching is going to appear on multiple screens. So I might be prefetching it on the list, your search results, but then I'm prefetching data that's going to be shown over on your details screen. So we need a way to make sure that that data is accessible from actually more than one activity if we're going to prefetch it oftentimes. Because if we just prefetch it and keep it local to that activity, the next activity isn't going to even be able to look at it. So there's a few different ways to do that. I mean, that may mean just say, hey, you pass it in as extras, you make it some sort of parsable, you pass it through as extras to that second detail screen. That way it can pick it up. It also may mean saving it to some sort of local SQLite database on the device that can be accessed from anywhere. That's the other way around that. So as we're kind of dealing with bandwidth, dealing with radio usage, one of the things we need to do is we need to monitor the connectivity state. We need to monitor what the state of those radios is, whether it be the Wi-Fi or the 4G, the 3G radios. We need to know when are they connected, when are they disconnected, because we only want to try and even send data when we know there is a connection. And we also So that's one part of it, and we also may need to adapt it as to say, hey, well, they're on a 3G plan that they only have, they pay for the data, versus they're on a Wi-Fi plan where they don't pay for the data. We may want to use a different strategy there. We may want to say, hey, if we're on Wi-Fi, we'll prefetch a whole lot of data because it's basically free, versus if we're on a 3G plan, we'll say, oh, we're not going to prefetch anything because just the trade-offs there are not as good. So that's another thing to pay attention to is you do have to pay attention to the connectivity manager and see where they're at. You also may want to monitor the battery. So if you go into the battery manager, you can monitor and see, well, what's the percentage of the battery? Are they 90%? Are they 20%? Are they at low battery? Obviously, if we're going to run something really intensive that's going to use a lot of battery, we don't want to run that when they've got 10% battery left. That'd be really mean to them, because then it's like, okay, your battery, we run this, we got halfway through, your battery's dead. Sorry. So we want to make sure that we run kind of battery intensive things. We want to run those when they're plugged in. So those are things we have to kind of watch for and pay attention to. So those are all things to consider. Again, to kind of quickly review, we generally want to bundle our data. That's important for efficiency. We usually want to do some sort of prefetching. We want to monitor the state of the network, the connectivity, and we generally want to monitor the battery. Okay. Now, the old way of doing a lot of this here used a lot of different pieces. What I'm going to show you today is a different way to do this, which was introduced, I think, in API 21, something called the JobScheduler. It's going to make a lot of this easier. But this used to be how we did all these things. So we'd start at the beginning, we'd have a broadcast receiver set up, and this would be usually something we'd declare in the manifest. We declare this in the manifest and say, well, we want boot completed broadcasts, we want connectivity change broadcasts, and we need battery change broadcasts. So we would look at all three of those. We would register for all three of those broadcasts in our manifest and say, well, send those to our broadcast receiver. Okay, so we know when it boots up, we know if they connect to Wi-Fi or disconnect from Wi-Fi, we know if they're charging, etc. So we would hook all those things up with a broadcast receiver. And then we'd feed that in and we'd say, well, when the broadcast receiver gets something, especially like the boot completed broadcast, then we'd say, well, let's start the service. Let's start a service that's going to run in the background and is going to monitor the internet for new posts, new stores, new blog articles, whatever it may be, new Facebook posts, whatever. That service would do the kind of the background work of our process. Okay, so that service is something that runs even if the app is not running. Even if the app stops, that service is still running, and that service is still something that can get started and initiated by these broadcasts, even if the user hasn't gone into it. So that's an important piece of that. And then the service, well, the service still running on the main thread, so we don't really want to do anything heavy on the main thread, Same thing with a broadcast receiver. Both of these are running on the main thread. So we still need to get off of the main thread. And so you remember in 7.1, we talked about one way to do that is with an async task. So this service might fire up an async task, tell it to execute, run on the background thread. In that background thread, it would use the HTTP URL connection object, which we set up. Remember the network utils class that we wrote? I think it was for who wrote it. We were hooking up to the Google APIs, Google Book APIs. But we'd use that HTTP URL connection to go and make the actual request. That would happen on that background thread. And eventually then we would say, okay, now we've got the data from the server. Is there anything new? And if there's anything new, then we send that notification off to the notification manager. So traditionally, in order to send notifications to the user, we had to hook all these things up. We had to hook every single piece of these. We had to create a subclass of broadcast receiver, a subclass of server service, a subclass of async task. And we also in here, one thing I kind of skipped over, usually also had to do something with quote unquote alarms or the alarm manager. We would use that to say, well, every hour I want you to start my service. Every hour I want to go look for new things, or every 15 minutes, whatever it may be. So that was how we also did it based on time. We brought in that alarm manager in addition to kind of know when things happened. Okay, any questions with this so far? It has been a few days since we talked about some of the pieces on this slide. Okay. So yep. So from kind of looking at everything that's here and kind of understanding that, I know it's been a few weeks since we covered, I think we covered broadcast receivers in 7.3. We covered async tasks in 7.1. We talked a little bit about this HTTP URL connection and connecting to the internet. We talked about that in 7.2. Any questions on some of the pieces that are on this slide? Okay. So one thing I might mention on this slide, you'll notice the alarm manager here, you'll notice the service. Those are two things. 7.4 would have been talking about the service component. 8.2 would have been talking about this alarm manager. Both of those we're skipping because the way JobScheduler works, we really don't need to know much about those two pieces anymore. So we're going to kind of be using JobScheduler in place of what those do. In fact, the JobScheduler, which I'm about to show you, it's actually going to take care of this whole top part. it's going to take care of, we won't really need to set up a broadcast receiver in general. We won't need to set up a service. We won't need to set up alarms. The job scheduler actually does all that top part for us, and actually typically does it better than what we could do ourselves. Because even if we set all these things up, we only have knowledge of our own app. We can't know what's happening with other applications on the device, really, as far as their interest in sending and receiving data. But the OS knows, the operating system, the Android operating system knows what other apps are wanting to do. So it's able to bundle requests from other apps as well as our apps so that they all happen at the same time, whereas that's something we couldn't really achieve just using all these pieces ourselves. Another note I might put in is this part down here. This is where Volley comes in for the async task, the HTTP URL connection. That's the part that Volley makes easier, is getting and receiving data from the network and running that on the background. So let's talk about JobScheduler. JobScheduler allows us to have intelligent scheduling of background tasks. It's based on conditions, not a strict time schedule. So we don't say that, hey, rather than strictly saying this has to happen every hour on the hour, and saying this has to happen exactly at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, which is what we had to do with the alarm manager. We had to be very strict about our timing. This allows us to be more flexible of, I don't necessarily care exactly when it happens. We'll let the operating system have some flex about when it actually does it. So it can do it when it's more optimal. When, say, the wireless radio is already on, or the battery's already charging, or whatever it may be. And bundling things together, so we're doing a lot of the network transactions at the same time. So it allows us to do a lot of those things intelligently without really actually requiring a lot of code. It's a lot more efficient than the alarm manager, which is part of why we just this is just the better way to do it. It does batch those tasks together. It does, however, require API 21 or higher, which for us that's not a big issue because all of our apps for this semester are targeting 21 or higher anyway. But that's something to keep in mind. There's not a support library really for the job scheduler. There is another tool in the support library called the Work Manager, which does a similar job, but it does it very differently. So it's not an easy drop in the compat class instead, and now it's working with the Work Manager. You actually have to generally change the code quite a bit between the Work Manager and the Job Scheduler. So there's three kind of components to making the job scheduler work. First, we need to create a job service class, and that's where the actual work of the job is defined. That's where we define what is it going to do when the job starts. When the job starts, here's the work that it needs to do. It needs to go to this website, download this file, do these things, interact with the database, whatever it may be. The job service is where we define the actual work that needs to get done. The next piece in there is the job info, and that determines the conditions for starting the job. So there we can define things like run the job every 15 minutes, run the job every hour, run the job once a day, and as well as, things like let's wait at least an hour before you start it. Here's the maximum amount of time that I want you to wait to start it. I maybe want you to wait at most 15 seconds to go start it. It's also where we can say, hey, well, this job needs network, so optimize it, only run it if there actually is a network connection. Or only run it if there is what we would call unmetered connection or Wi-Fi connection. You can also say only run it when the device is charging, all of those conditions, which we'll go over in a minute. So our job service is where we define the work. JobInfo is where we define the conditions to start that work, and how that, when and how that should happen. And then the job scheduler is where we actually schedule and cancel those jobs. So the job scheduler will give it a job info object, and then the job scheduler will figure out when to actually run the job and figure out what jobs are actually running. So let's start with the job service. So to create the job service, we need a subclass, the job service class. We implement our own work there. So in order to implement that job service class, we need two things. We need an on-start job method, and we need an on-stop job method. Both of these two methods run on the main thread, so keep that in mind. If we need to run it on a background thread, we will need to offload that to another thread manually. Okay, let's start with on-start job. So on-start job, any work we do there, that's where we implement kind of the work to be done. That's going to run anytime those job info conditions are met. It's going to run on the main thread. If we do need to run heavy work, we need to run network operations, we need to send or get anything from the internet, or work with the file system, or work with a database, we need to make sure we offload that to another thread. So that may mean offloading it to, say, an async task, or really usually just a straight up thread, or using the executor or things like that. But typically, you would just offload that to a regular thread. Okay, so if on-start job has to return a Boolean. If it returns false, then that says that the job is finished. It says we ran this on the main thread. It's all done. There's nothing left to be run. So that you're going to run for short jobs, anything that doesn't need to interact with the network. But if it is a long-running thing and we did have to spin up a background thread for that work, then we're going to return true instead. So that return true says that the work has been offloaded to a background thread, to some sort of worker thread. Well, then in that worker thread has to call job finished to say, okay, now I've finished the job. It has to then let the scheduler know when you're finished. Okay. When we call job finished, we'll need to pass in the job params object that we got from onStart job. onStart job takes a job params object, and that includes anything that you've added kind of in the job info object to say, here's your conditions for the work you actually want to do. So that may be a URL to a website, or that may be, I want movie 53, or I want movie 27, or I want user Paul Smith, or I want to know about blah, blah, blah. So that's any kind of details that you need to know about the job that's running. Because again, you can kind of run multiple of these jobs at once. So job params keep straight which job are we talking about. Okay. We also need to implement onStop job. So the onStop job gets called when the system determines that you need to stop. You need to stop ahead of prematurely. OnStop job only gets called if we're doing things on the background thread. So if you remember on the previous slide, if we say return false and we're doing all the work on the main thread, we're not going to see OnStop job called. But if we're offloading it to a background thread, we're going to get this onStop job method, and we're going to need to tell our background work to stop. We're going to say, hey, something's changed. Please stop what you're doing immediately, and we may or may not reschedule it later. But that means that generally when you get that onStop job, that means that the conditions are no longer met. So whether that means that if you said you needed network, you said you needed a Wi-Fi network for it to work, then that Wi-Fi network's not there. If you said that the device needs to be charging and that's not charging anymore, or if you maybe took too long, all of those things can result in your job being stopped. So those are things to consider. That on-stop job will be called before you call job finished. Because remember, job finished is the way you tell the system, if you're running on a background thread, that you're done. So this will be called before that would be called. If we return true from on-stop job, then we're saying, okay, we've stopped it. Please reschedule it at a later time. If we say return false, then we say, okay, just give up on that job. We don't want to do that again later. Just give up on it. So that kind of depends on what kind of job you're building. Some jobs we want to say, well, okay, yes, we do want to retry that at a later time, reschedule that at a later time. Some jobs we're going to say, oh, it's just a one-time thing. That was the user initiated it basically, and we're going to say, oh, I don't really care about doing that again. So just drop it. So an example of what that might look like, if we're creating our own job service subclass, we're going to say, hey, this is my job service. That's the name of this class. It extends extends job service. Inside of here, we've got some async task subclass. That's where we're going to actually be doing the work. And that work, remember, in that task, when it's done, it's going to need a call job finished. Okay. So in on start job, we say task execute, give it the parameters, and then say, okay, we're going to return true to say we've offloaded the work to a background thread. If on stop job gets called to say, hey, we need to end it prematurely, we're going to cancel that task, and then we're going to say return true because we do want to reschedule it in this case. So that might be a kind of basic structure of how you build a job service if it's offloading to a background thread, which most of your job service, most of your job services will be offloading to a background thread. Now that being said, we're probably going to do that offloading through Volley most of the time. So Volley will kind of deal with running that background thread. But we still have to consider things like, well, what happens if we need to stop the request prematurely? So any job service we create, we also need to register that in our manifest. So you remember in our manifest, we've got that, we've got the application tag. Inside of the application tag, we put different components. So we're going to put our activities inside of that application tag. We're going to put our broadcast receivers inside of that application tag. We're also going to put services in there. And the reason we have to do this is because job service is actually technically a subclass of job service, technically a subclass of service, even though it doesn't really work like a regular service. It is still a subclass of service. So we do have to declare that job service in our manifest. So we tell it the Android name, that's the name of the class, and then I have to add this Android permission bind job service to allow the operating system to interact with this job service, because the operating system is actually going to be starting it up when the conditions are met. We won't start it manually. Okay, so to define the job info, job info is going to define those conditions for running the job. In order to build the job info, to create that, to define the conditions, we're going to actually use JobInfo.builder. Okay, so that's how we define those conditions. So we're going to say JobInfo.builder. We're going to create a new one of those. We need to give it a job ID, but we also need to give it this thing called a component name. So a component name is kind of a way to know the name of a class, or the name of what we call component, which can be services, which can be broadcast receivers, which can be activities. Again, all three of those are components. In this case, we're specifically a service. That component name is used because the Android operating system, another app effectively, is creating or starting our service. If we were starting our service ourselves, we wouldn't necessarily need to do that, but that's part of how JobScheduler works, is it starts it on our behalf. So we need to provide it this component name. This component name has two pieces in it. It has the package name, which is basically the name of our app, as far as the operating system is concerned. And then we've got the class's name. So we're going to say get package name. This is something we call on a context. So we get the package name and we get the name of the class. Put those two things together into a component name, and we effectively have the name of our service. Okay. So put those two things together, and I provide that as the second argument to the JobInfoBuilder. So that tells it what the name, what job service that this is going to run. The job ID, if I remember right, is an integer. It is something that we need to have unique as far as our application is concerned. So I can have multiple job ID zeros, but in different apps. But my specific app can only have one job ID 0. So all the jobs we start have to have a different ID. So typically we'll put that in a constant, and we'll store that in some place where everybody can get access, so we don't use the same job ID in different activities or different places. So different conditions that we can set. We can set conditions on the network type. We can set conditions on the back-off criteria. Back-off criteria has to do with what happens if we need to stop the job prematurely and then it needs to be rescheduled. So the back-off criteria comes in there if we need to reschedule a job that's been canceled prematurely. The minimum latency, that's the minimum amount of time that we want to wait for starting the job. Override deadline, it's like, well, if it doesn't get started by X amount of time, then go ahead and start it. Periodic is how we're going to set up repeated. We're going to say, I want to run this every 15 minutes. I want to run this every hour or every day. That's how we kind of set that. Set persisted, another useful thing that says, well, when the operating system shuts down and restarts, still keep this job. Keep this job even if the operating system shuts down and restarts, which is really useful for some of those things where we would have used an alarm manager or the boot completed thing in the past. Set requires charging. We can say only run this when the device is charging, only run this when the device is idle. So there's a lot of different methods there on the JobInfoBuilder class. You want to read up on those. There's some additional ones that aren't even mentioned here, but these are the ones that we will be the only ones that we really need to know for this course. So let's start with the network type. So the network type is an integer. There's a few different constants that we can use to specify what kind of network type we're interested in. So we can start up at the top, we can say none. We say, I don't need a network to run this job. I'm not going to access the internet. So that would be network type num. I can say network type any, say, yes, I need a network connection. I need to be able to get out to the internet, but I don't care what kind of network connection it is. Any network connection will do. The next one we say is not roaming, so that would be any network connection that's out there as long as it's not like roaming. So you're not going to incur roaming charges and such like that. And that would be like a 3G, 4G sort of network. The last one in there is something called unmetered. So unmetered is typically a Wi-Fi connection, is usually what that means. But more specifically, it means a Wi-Fi connection that isn't charged or billed. It's a network connection that's not billed per usage. So that would be a Wi-Fi connection for your home Wi-Fi network, but not a hotspot Wi-Fi. So if you're running off a hotspot, that's not an unmetered connection because you're still being billed for usage. So the next condition we can put on there is the set minimum latency. So it says this is the minimum number of milliseconds that we want to wait before starting the task. Even if all the other conditions are met, we're still going to wait this amount of time before we start it. This is not set by default. This is something we add in if we need it. So I might say, well, I don't want this job to run at least for a few seconds because of other things going on and other things that may be happening with the system. Okay, we can also set this override deadline. The override deadline says, even if the conditions aren't met, I don't want to wait forever for my job to start, so cut it off at this period of time. So if maybe the network doesn't come online, or the battery isn't plugged, the device isn't plugged in, or whatever it may be, whatever the other conditions are, if they're not met, then go ahead and run the job if we get to, say, 15 seconds or 30 seconds or a minute, whatever that number may be. Note that both of these, the minimum and the override deadline, both of these things are set in milliseconds. But both of these things are not set by default. Okay. Third thing we can do is we can say set periodic, and this is also in milliseconds, but this does not work with either the minimum latency or the override deadline. If you have a minimum latency or the override deadline, you can't use set periodic. So set periodic is only without those things. So set periodic says this is something we want to happen repeatedly, and we want to have it happen frequently. This is probably one of the most used conditions when we're talking about notifications. But we're going to say give it some sort of repeating interval. This is how long we want to wait. Note that it needs to be specified in milliseconds. It's not guaranteed to run in that amount of time, or not guaranteed to run in that interval. The operating system will flex it. It'll try and run it at a time when say the radio is already, if you need the radio, it's going to do it when the radio's online. It's going to, if you need to use the radio, it's going to try and bundle connections together, tasks, jobs together, so that if multiple apps, let's say 5 different apps, need to go get into the internet and need to access network resources, it's going to try and do all of those at once, rather than spreading them out. So that may mean that your repeating interval isn't exactly every 15 minutes. It may be 10 minutes here, 5 minutes there, 15 minutes here, but it's going to be always run at least once. It's always going to be, run exactly once within that interval that you specify, is what it basically means. So if I say my interval is 15 minutes, it guarantees that every kind of 15-minute window, it'll be run somewhere in there, but it won't be run twice, typically, in that same window, but it may be longer or shorter. It may be a different point in that window. One thing to note, as of API 24, there is a minimum interval on this of 15 minutes. But it's not something I knew about initially, so I think there's still a kind of an error, and this wasn't on the slide. So there is an error on the Fortune Cookie Lab. I think I had set the job scheduler up to run every 30 seconds. Obviously, that's much less than 15 minutes. So for the Fortune Cookie Lab, you'll need to have that happen every 15 minutes. I think I pushed that up, an update to that, so it says 15 minutes now, but that's where that's at. So it'll be every 15 minutes, not every 30 seconds. Another condition we can put on there, and this is not really so much a condition, but we can say set persisted is true. So if the device stops, if the device is rebooted, this job will continue to be there. So typically we use this in combination with the set periodic. So we're going to say run this every 15 minutes, but also persist it so that if the device is rebooted, that it will come back and resume when the device comes back up. We do need the receive boot completed permission in our manifest to be able to use this condition for it to work. This is actually how we get rid of needing to, using this as persisted is how we get rid of needing the broadcast receiver at the beginning that receives that boot completed event. So we just say, well, this job is going to be persisted, so I don't need to then set up my own boot completed broadcast receiver. But by default, that is false. So if you do want it to be persisted, you need to specify that. We can say it requires charging. By default, jobs don't require charging, but we're saying, hey, we only want this job to run when the device is plugged in. And that's usually for things that are battery intensive. So let's say I want to update all the GPS data. I want to update a lot of that. Well, that's a lot of data. It's pretty intensive. So those things typically only happen when you're charging. So that's one thing to keep in mind. That's probably not something you want to say most of your typical jobs need to be connected to, need to be charging in order to run, because that means they're only going to run maybe once a day. But you probably will in the end find that you have at least one job in a real world app that kind of needs that needs to be running or makes sense to run when the device is charging. That may be prefetching data. It may be, to some sense, looking at notifications, although notifications we usually kind of do when, even if the device isn't charging. There's another setting called requires idle, and this one's a really fuzzily defined condition. The idea is that the job should run when the user is not using their phone, okay, or not using their device. So we're saying this job should only run if the user's not using their device. What that means is really up to the manufacturer of the device. So Samsung may make one decision, Google may make another, LG might make another, Plus One might make a different decision about what idle means. But we're saying the intent is that this is when the user's not using their device. They've got it turned off, they've got it put on the corner, and they haven't touched it in the past several minutes. So that's the theory about what idle means. It means that nothing else, the user isn't actually interacting with it. It's meant to be used for the most resource-heavy jobs. This is where you'd want to do them. You want to say, okay, I only want to run this when the user's not touching the phone because I don't want it to like stutter on them. I don't want them to be dropping frames while this is happening. So that's what that means. So again, you might have one of those. It oftentimes, say, requires charging and requires device idle. Those usually go together. But you're probably only going to have one or two of those jobs in a real world app. You probably won't have any of those that requires charging or requires idle for the projects we do in this course, especially your final project will probably not need that. So let's get an example for how do we build up this JobInfo object. So kind of rehash. First step I need to do is I need to create a JobInfoBuilder. I need to provide that job ID and the service name, the name of the component. So that needs the package name and the name of the job service class. So we put those two things together, we get a component name. And then we just add the conditions. So we say this job needs a unmetered network connection, so we add that. We say this needs to be idle, the device needs to be idle, and the device needs to be charging. So we put 3 conditions on it. So it won't run until all of those 3 things pass. And notice that we haven't set an override deadline. So this could sit out there and be that way for a long time if those conditions are never met. If they have a device that doesn't have a SIM card in it and they haven't enabled Wi-Fi, or then this may never run. So usually most of your jobs, if you're not going to set them up as periodic, you will probably want to always put an override deadline on there so that they happen eventually. Otherwise, you may get into a case where that job just never runs. Okay, and then finally we call build. Build is what takes the JobInfoBuilder and turns it back into, actually creates our JobInfo object, which the JobInfo object is what we really need to pass into the job scheduler to tell it to start that job or schedule that job. Okay, so we talked about the JobInfo, which is those conditions for running the job. We talked about the job service, which is the actual logic of the job. And the last piece that we need to talk about here is the actual job scheduler. So the job scheduler we get from the system. It's another one of these system service objects. So we're going to say get system service, job scheduler service. That's a constant. We're obviously calling get system service on the context as usual. So we're going to say get that, save it, and then once we have a job that we need to schedule, we're going to say take the scheduler and schedule it. Typically, if you start working with the job scheduler, you're going to need to use it at a few different points. So saving the job scheduler to a member variable, as you can kind of guess here, is usually a good idea. It's not required. You don't obviously have to save that job scheduler to a member variable, but it's usually worth it simply for kind of the savings that you're going to get from not having to call get some system service every time you need it. So that's how we schedule a job. We get the system service, and then we call schedule. Usually pretty simple. If we want to cancel a job, which actually this should be cancel, we're going to, again, get the system service and then cancel it. So we can put that into one step. We can say, well, let's just reuse the system service. We say we'll get system service typically in the onCreate method, and then wherever we need to schedule or cancel jobs, we'll just do that. There's some additional articles that you can read up to find out more about the job scheduler and such. And then that's kind of it. So the big reason that we want this, again, the goal is to make more efficient use of our battery as well as more efficient use of our data, because we don't want the user to be running have to charge their phone all the time, and we don't want the user to necessarily be paying a bunch of money on data. So that's what the job scheduler is for. Now, job schedule usually comes into play a lot with notifications. That's usually the place that is best used, is to say, I want to find out if there's new data and show the user a notification. So those usually go very much hand in hand, which is part of why, that's one of those things that's on several of those labs, is to kind of, I want to do is how to work with those things together. As well as you can expect that to be on the next hands-on test, using the job scheduler and sending notifications and doing background work with the network and Volley there together. Okay, so again, to review the three parts, the three components that you need to have there for the job scheduler to work, you need the job service first, which is what does the work, the job info, which specifies the conditions, and then use the job scheduler to say, I want to schedule the job or I want to cancel the job. Okay. Questions? Next test. I'll hand it out on Monday next week. I'll post it up on Inside Reagan. And I believe it's due by the end of Wednesday next week. So I'll post it next week. You'll have a few days to work on it. And they'll be due Wednesday of next week. Wednesday at the end of class. We'll see how much time we have for the final. My hope is to have 2 weeks at the end of the semester to work on it. But obviously there's a lot of things in flux that I don't know about our schedule, because I don't know if we're going to, what classes are going to look like. I don't know what things are going to look like. So hopefully we'll have about 2 weeks to work on that final project. That's the plan. We'll see what actually falls out. That'll probably be the last 2 weeks of April that you'll be working on your final project. Best option for sending notifications. Might have to expand on that question. So typically for sending notifications, let's say our specific example is we're looking for maybe your fortune cookie lab. So we want to say there's, or actually maybe a news story. Let's say we want to say, let's look for if there's a new news story out there on the website. What I might say is, okay, well, so let's define an interval. So let's say every hour we'll go look. And how frequently we looked is based on what kind of data we're looking for. So if we're saying it's probably only going to be posted once a day, and we don't really care necessarily when the user gets that notification, it doesn't have to be close to the time that it's posted, then I might just set the interval every day. But a typical interval might be every hour. So every hour I'm going to go look, is there a new news article? If there's a new news article, we're going to then show the notification. So if I'm looking every hour, I'm going to need to say set periodic, set that to an hour. I'm going to need to say set required network type to any, because I need to be able to get out to the internet to see if there's new articles. So I need really those two conditions for most notification setups. And you say there's a network connection, and here's my periodic interval. That's how I'm then going to hook up that. That's how I'm going to specify the conditions. Is the periodic, and that requires a network type. And then that job service that I implement will use Volley to actually send the request and check. And then once I get that request, the response back, then I can analyze that and see if there's new data, and then send the notification at that point. So as far as your labs for today, now that we're done with this here, so there's a concept chapter to read up here. So read through that. And then the practical. So the app, there's the app for your coding challenge. It's going to be to kind of configure your own job and kind of play around with these conditions and see how they work. And then it's going to send a notification when that job runs. So that's the kind of the code lab that you're going to go through. You're going to go through task 1 and 2. And then I do want you to do the coding challenge for that. You do, however, not need to do the homework lab for that, just the coding challenge. Once you finish up with that, then you'll move on to the volley labs to finish up those 3 that you haven't done yet. So remember, Magic 8 Ball, Chatterbox, and the Fortune Cookie. Those are the 3 that I want you to do. And then tomorrow, I'm planning to do another live stream, and we'll talk about, I want to go through an actual code example of how to use the notifications, the job scheduler, notifications, and volley, all of that together. So we have an actual concrete real world scenario of how to use all these pieces together. So that's the plan for tomorrow. Okay, so I'm going to end the stream here. If you have any more questions, please post them on Discord, and I'll be in touch.